Hello once again. For the next several weeks, we'll be going through some topics dealing with electricity. And we'll start off with some of the very basics here today with static electricity. Found a great meme. Some of y'all know I have cats. This is what cats do. I don't know. In this case, you see the cat. It says, yeah, real funny. Rub me on the carpet and then put me in the shipping box. You'll pay for this. You can see that the stuff is sticking to the cat. We'll be talking about some things you already know about and have had some experience with, but we'll kind of science it up a little bit and try to get some scientific explanations. So as we're going through this today, we're going to try to answer some of the following questions. What is static electricity? What causes it? And how can we get objects to become charged? And some of the vocabulary, again, static electricity, conductors, insulators, friction, repel, positive, negative, words that you probably have come across somewhere between 8th and 10th grade science already, but we're going to put them back together for you. This first unit is called electrostatic, which sounds like a big kind of scary word, but it's got a couple parts in here. You can see the electro part of it being having to deal with electricity. And so this is kind of our physics, that deals with the attractions, which are coming together, and repulsions, pushing apart, of electrical charges, and that they don't depend on their motions. So in other words, at rest, what happens to attractions and repulsions, what happens to electrical charges just because of the way that something is, right? So fairly simple stuff, even though that's kind of a big word that we have there. What causes these attractions and repulsions? This goes back to our chemistry class. So we're going to think about our subatomic particles. So we're going to go back into our protons, which have the positive charge, and our electrons, which have a negative charge. And fundamentally, this is what's going to cause static electricity. It's what's going to cause electricity. It's what's going to cause things to be attracted to one another or repelled from one another. And so when we think of a charge, what we're really thinking of is here's a definition. It is a fundamental property to which mutual attractions or repulsions between electrons and protons is attributed. So in chemistry class, we talked about how protons were positive, electrons were negative, and that just, there's nothing to me that I can really say that what is it to be positive, what is it to be negative, but the positive charge and the negative charge kind of tells us what's going to happen to its motion if we bring them near something else. So if we bring two positives together or two negatives together or a positive and a negative together, there should be an attraction or repulsion between the two based upon this property. So that's just kind of the best way we can think of it. It's hard to think of a negative charge without thinking of a positive charge, and you can't really have necessarily a positive charge without negative. They tend to kind of go together with one another. Substances can also not be charged. Again, they can be neutral. So again, if something's neutral, it's neither positive nor negative. And so that would simply mean there would be an equal number of positives and negatives. So again, that's supposed to be equal positives and negative charges. So everything's balanced out. It's neutral. There is not a charge. Now, within the atom, the protons are kind of embedded down in the middle, but the electrons are on the outside. So electrons are the things that can move around, and because they can move around and because they're on the outside, they can sometimes come off of the atom or they can come onto another atom. And so electrons can come and go. And as they come and go, they're going to carry their charge with them. And since electrons have a negative charge, they're going to carry that negative charge with them. So if something gains electrons, it's going to be gaining negative charges, and it's going to get building up a negative charge. Consequently, if something's losing electrons, it's going to be losing negatives. And if you're losing negatives, that results in a positive. Kind of like a bank account. If you want to think about what a negative would be, that'd be like spending. You know, if you spend, you end up, becoming negative. But if you lose a negative, like if that's kind of like saying losing a debt, right? If you lose a debt, that in effect is almost like getting paid, which would be kind of a positive thing. So losing an electron is going to result in a positive charge because it's taking away a negative. Right? When we talked about atoms in chemistry class, this is how we referred to ions. So an atom that would lose an electron will become positive. An atom that would gain an electron will become negative. But substances themselves, like a pencil, anything around us, they can also gain electrons or lose electrons and become charged. And this is more what we're talking about now, is the bigger picture of things. Substances themselves, large things that we see building up charges, as opposed to just discussing the atoms. When we bring things together. They may get pushed apart or they may get pulled together. And so we tend to say like charges repel. So repel means to push apart. And so if you have two positives, they push apart. If you have two negatives, they also push apart. So similar charges kind of get pushed apart from one another. It is the opposite charges that attract. Positives and negatives attract one another. Protons and electrons attract one another. A positively charged substance and a negatively charged substance would attract one another, which leads us to static electricity. Again, static electricity is kind of like, say, electricity at rest. It's not something going through a wire. It's not lightning coming from the sky. It's just, we're talking about the amount of electricity on an object due to its either buildup or loss of electrons. So we're talking about confined to an object. Got the little meme here. The girl with socks all over. See that she's got some static electricity built up on her. So we're just talking about how much electricity an object would have because of the amount of electrons that's on it. We often use this word affinity. In everyday language, the word affinity means a liking of something. And so when we're talking about electron affinity, that means how much does something want to hold on to an electron? How much does it kind of like an electron? Different materials have different affinities. So different things will build up static electricity differently. Some materials hold electrons better, which means they're going to end up becoming negative because they hold on to them. Some materials don't. Some materials lose them pretty easily, and they end up usually becoming positive when you rub them together. Which brings us to the next part is how do we get an electron to move? There's several different ways. One of the first ones we'll go over now is friction. So when we have two objects rub against one another, the electrons on one object may get pulled off of it and go to the other one if there's a difference in the affinity level. And again, if you just rub your hands, you're not really going to have anything building up because each hand should have about the same affinity. So if I'm losing any electrons from my right hand to my left hand, the same thing should be happening back and forth. If I rub two pieces of paper together, that really shouldn't cause electrons to build up on one or the other. But if I rub two different substances together, one object may lose electrons at a greater rate than the other one, and that's going to cause a change in the charge because one of them is going to be building up negative charges. So an example in this little picture down here, like if you have a cloth like wool rubbing on a plastic pipe, the cloth might lose its electrons to become positive. The pipe might gain the electrons to become negative, and we would see then some attraction between the two that could cause movement. By rubbing them together like this, we can then say the objects have become charged. One has become positively charged, one has become negatively charged based upon the motion of the electrons. You notice friction around you all the time. If you pull clothes out of the dryer and you see them sticking together, oftentimes that's because of the static electricity. Sometimes even if you pull them apart in the dark, you can actually see the electricity kind of going between the two. If you ever taken a balloon and rubbed it to your head, it can stick to things at that point because it now has built up electrons. If you walk across the carpet in your socks and then touch the door, you're going to have a static discharge because as you walk across the carpet, you're going to end up building up electrons on yourself. And those electrons don't like to stay there. They like to kind of discharge themselves and to come back neutral. So if you give them an opportunity, they're going to kind of flow out of your body. But we can tend to build up static electricity in a number of different ways with this. We don't need to memorize this, but if you have a chart like this, it's kind of this one says an attraction for electrons or the affinity for electrons. And so at the very top, this says these hold electrons tightly, so they're going to have a high affinity, like PVC. This would be like plumbing pipe. I think we have this that we'll be using in class, but so this would be like PVC pipe. It's going to have a very high affinity for electrons, holds onto them tightly. And as you go down the list, things become they don't like electrons quite as much as you go down, and by the time you get to glass doesn't want to hold electrons at all. So we can predict if we rub a couple of these things together which way the electrons will go. The electrons kind of want to go to the one that's going to be up at the higher part of the list. So if you rub silk and wool together, we would expect the silk to grab onto the electrons a little bit more and become more negative, and the wool would end up becoming a little bit more positive. So if we go through a few questions to predict, again, we can kind of look at these. If you pull a wool hat off your head, what charges would be produced on your hair and on the wool cap? If we come over to our chart over here, we can see wool is towards the bottom, but hair is even closer to the bottom. So again, as you go to the bottom, these are the ones that are going to lose their electrons. And if you lose an electron, you're losing a negative. If you lose a negative, you're going to become positive. So we would expect the hair to become more positive. We would expect the wool to become more negative. And again, they would still kind of attract one another. The wool hat might pull the hair up, but the wool is the one that would be the one with more electrons. Which will produce the most static cling with a cotton t-shirt, wool or nylon? So again, if we look at cotton, cotton wants to hold on to electrons pretty tightly. If we compare it to wool, which is further down the list, and nylon, which is even further down the list, we would expect the nylon to lose its electrons even better than the wool. So the nylon, because it's closer to the bottom of the list, should lose its electrons more easily, and it should cause the charge to build up on the cotton even more. So nylon and wool, again, the farther apart they are, the more the electrons are going to want to move from one to the other one. Should there be any static cling if only cotton items are in the dryer? Well, if you've got a bunch of cotton rubbing around, then you shouldn't have a net buildup of electrons. Just like with my hands, since it's the same substance, electrons are going to be moving, but they should be moving at about the same amount. Right? And then finally, predict the charges on the underlying object. So if I rub a rubber rod with fur, so rubber is at the top, fur is kind of in the middle, what's going to happen? Again, the rubber is going to be the one that holds its electrons more tightly. So we would expect it to become negative. The ones that lose their electrons would become more positive. So we'd expect the rubber rod to become negative. If we rub a glass test tube with silk, glass is way down here at the bottom, which holds its electrons very loosely, which means it should lose its electron. And if you lose a negative, you're going to become positive. So the glass test tube should become positive, while the silk should become negative. And again, if we take the PVC pipe, which is at the very top of the list, this one grabs onto electrons really well. If you rub it with nylon, PVC pipe is going to have a negative charge build up on it, and the nylon is going to have a positive charge. Okay. So fundamentally, what causes static electricity is going to be about the electrons. And how do we cause electricity? In a lot of cases, we can rub things together. Objects that grab onto electrons and have a higher affinity for electrons are going to have a negative charge build up on them. And with that, we can cause an attraction with something that might have a positive charge with it.